All right, number 18, we have in the xy plane, x plus y equals k, where k is a constant, and it's tangent to the graph of y equals x squared plus 3x plus 1. And we want to know what the value of k is. So first off, this line is the tangent line to this graph, which means that the slope of this line, which happens to be -1, right, should be the derivative of this, right? The slope of the tangent line is the derivative of our function. So -1 should equal 2x plus 3. And that should tell us that x is equal to -2. And if x is equal to -2, we should be able to figure out what y is equal to. And if x is -2, y is 4 minus 6 plus 1. If I just plug in -2 to this, which is -1. So if x is -2 and y is -1, we should know that -2 minus 1 equals k, or k is -3. Good or no? Everybody feel okay about number 18 there? All right. Number 19. Now, number 19 is a fun one. So many people missed number 19 back in 2008. People weren't as smart back in 2008 as they are now. So many people missed this question that they removed it from the test, which is sad. They should have punished all those people that weren't smart enough to get it right. Should have punished them severely. That's fine. You should be clued in when it says what are all horizontal asymptotes, that there might be more than one. And that, how do we determine horizontal asymptotes? Well, there's a horizontal asymptote to the right if you look at the limit as x approaches infinity. But then there's a horizontal asymptote to the left if you look at x approaching negative infinity. And so as x goes towards positive infinity, this 5 and this 1 become insignificant, and 2 to the x and 2 to the x are the same, but the negative in the bottom gives us a -1 here. But as we go towards negative infinity, like we said before, this value here of 1 minus 2 to the x, right? This 2 to the x, as we go towards a negative infinity, that effectively becomes like a positive, and that's going to cancel out with this term up here, right? And so we end up getting, and this becomes a negative, because a -2 to the negative infinity. So we've got a 2 to the infinity, and we've got another 2 to the infinity that comes up here. And so we end up canceling that out, and we end up getting a value of 5. And so the answer should have been E, but lots of people that year only put choice A when it should have been E. So.
Can you explain again why it would end up being 5? I think I'm like losing you on why it would be a positive infinity on the top and a negative infinity on the bottom.
I hope that's not what I said. Hopefully that's not what I said. These negative infinities, they go in here, right? This is a 2 to the negative infinity. And this is another 2 to the negative, a 5 plus and a 1 minus a 2 to the negative infinity. This 2 to the negative infinity is like 1 over 2 to the infinity, right? Both of these is like 1 over 2. Oops. 1 over 2 to the infinity. So if I get rid of those, I have 5 plus 1 over 2 to the infinity. I'm writing this really horribly. Let me write it on a separate page here so it's easier to see. 5 plus 2 to the negative infinity. 1 minus 2 to the negative infinity. So this becomes 5 plus 1 over 2 to the infinity. And this becomes 1 minus 1 over 2 to the infinity. Does that make sense?
Yes, it does make sense. Thank you.
Yes, and then those are both 0. And so it's just 5 over 1. I don't think I explained it very well the first time.
It makes sense now. Thank you.
Oh, good. Well, I was going to graph it. There's no reason to graph it. You wouldn't have had a graphing calculator. Any other questions there on those two, 18 or 19? Are those all right now? All right, let's look at 22 and 23. Maybe. That's what I said. All right. All right, 22 and 23. So 22, we have a rumor spreading among a population of capital N people, and it spreads at a rate proportional. So whenever you see it spreads at a rate proportional to something, that tells you that you're going to have this constant of proportionality, this K value that these all have in them. Okay. So it should be proportional to the product of the number of people who have heard the rumor and the number of people who have not heard the rumor. Well, that means that if P is the number who have heard the rumor, and capital N is the total number of people, that means that our differential equation should involve both a lowercase p and a capital N, which none of those three do. Right? So it's only B or C that we could possibly be having as our answer here. And so the rate of change of the number of people that have heard the rumor should be that constant of proportionality. And then it should be the product of the people who have heard the rumor, which is P, times the people who have not heard the rumor. And the people who have not heard the rumor is all the people minus the people that have. Not the people that have minus all the people, which is what choice C is. Does that make sense there for 22? Any questions there on 22? All right, 23, we just need to separate our variables. Y dy equals x squared dx. Y squared over 2 equals x cubed over 3 plus our constant. And then our initial condition is that y of 3 is -2. So when we plug in when we plug in 3 for x, we should get 9 plus c. And we plug in -2 for y, we should get 2 over here. So our constant should be a -7. So we end up with y squared over 2 equals x cubed over 3 minus 7. We need to multiply by 2. And then we need a square root. So we got a square root of 2x cubed over 3 minus 14. But the question is, do we have a positive square root or a negative square root? Because both those are the same, except one's a positive square root and the other's a negative square root. Well, the only way we can determine if we want the positive or the negative square root is by looking back at our initial condition. When we plug in 3 for x, we need to get -2 for y. Well, the only way to get a -2 for y is to have a negative out in front of your square root. Good or no? Any questions on that one? No? Everyone's good? Are we sure everyone's all right there? All right. Next one. Let's see. Well, I'm going to go slightly out of order of what people said just because now I'm already on the right page for this. And somebody wanted 24 and people wanted 25. So we'll do 24 and 25 next. So 24. A function f is twice differentiable. And we know that f of 2 is 1, f prime of 2 is 4, and f double prime of 2 is 3. What is the approximation of f of 1.9 using the tangent line? So a tangent line approximation should be just from the point. So our point is 2, 1, and our slope, which is 4. This information is totally unnecessary. They just gave you that to screw with you. There's no reason for f double prime of 2 equaling 3 to be there at all other than just to make sure you know that you don't need the second derivative to write the equation of a tangent line. So our equation should be y minus 1 equals 4 times x minus 2. And when we plug in 1.9, we should get y minus 1 equals 4 times negative 0.1. That's negative 0.4 plus the 1 should give us 0.6. Everybody good there with 24?
Would this also work with linearization?
As in writing out the formula like f of a plus f prime of a times x minus a? Yep. That's the exact same thing. Yep.
Okay, yeah.
Yep, because your a value is just 2, so you're looking at f of 2, which is your 1, and then f prime of a, which is your 4, and then times your negative 0.1 when you subtract them. Yep, exactly the same.
Wait, so I'm a little confused. Would linearization and just writing the formula of a tangent line be the same thing, or is there a specific reason why you'd use linearization?
So they are literally the exact same thing. That's what linearization is. It's just a point slope form of, at some point. We call it linearization specifically when we're working with like, usually when we're working with something like, find the square root or find the cube root of some value, like 124. What's the cube root of 124? We usually say we're going to use a linear approximation or linearization, but a linear approximation or linearization or tangent line approximation, they're all literally the exact same thing. It's just different terminology. Sometimes we'll use it in one terminology in one instance and another in another different instance, but it doesn't mean anything different. Does that answer your question?
Yes, thank you.
Oh yeah, of course. All right. So we've got let f be the function defined where c and d are constants. If f is differentiable at 2, what is the value of c plus d? So 2 things to note. One is that if f is differentiable, that also tells us that f is continuous. So we're going to, in order to figure out the values of c and d, to figure out what c plus d is, we're going to have to write a system of equations probably. So we're going to use the fact that it's continuous and the fact that it's differentiable to help us do that. So if it's continuous, it means that the limit from the left must equal the limit from the right. So the limit as x approaches 2 from the left of f needs to equal the limit as x approaches 2 from the right of f of x. And if we remember anything about limits, the first thing you should do is just plug in the 2. So the limit from the left is 2c plus d. And from the right, it should be 4 minus 2c. So we should have that as our first system of equations. And then we should take our derivative. F prime is equal to c for x less than or equal to 2. And f prime is equal to 2x minus c for x greater than 2. And if this exists, if it's differentiable at 2, it means that when I plug in 2 for x, these should be the same. So c ought to equal 4 minus c. And if I solve that, that should tell me that C is equal to 2. And if C is equal to 2, I should end up with D is equal to negative 4. It looks like that becomes a 0. So negative 4 equals D. Yep. And so C plus D ought to be 2 minus 4, or negative 2. Does that make sense to everybody or no? All right, everybody's good? Okay, next one we're going to do is 28. I think that's the last of the non-calculator ones from this, although there is another one that somebody asked for we'll go back to before we do the calculator ones that people asked for. So here we go, 28. Oh yeah, that's a good one here too. So we got f as a differentiable function, f of 3 is 15, f of 6, blah, 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 give us a bunch of values. Right. It says g is differentiable and g is the inverse of f. We want to find the value of g prime of 3. So this is the inverse rule. Okay. Clearly that g and f are inverses, so we know that g must contain a point 3, comma, something, which means that f must contain a point something, comma, 3. So g prime of 3 ought to be 1 over f prime of whatever this x value is. Well, when does f equal 3? F equals 3 at 6. And that's the point 6, comma 3. So if we want g prime of 3, that should be 1 over f prime of 6, which ought to be 1 over negative 2. And that's just the inverse rule. Good or no? Any questions there on that one? All right. I just accidentally closed the 2008 test. Don't worry, it's back. My computer is only freezing slightly. All right, number 16 was the next one somebody asked for. So we have sine xy equals x. We want to find dy dx. So we'll differentiate both sides implicitly. So the derivative of sine xy ought to be the cosine of xy times the derivative of xy. And to find the derivative of xy, we have to use the product rule, x, and then the derivative of y, y times the derivative of x. And then equals the derivative of x on the other side, which is 1. So now we're just solving for dy dx. So we can do 1 divided by the cosine xy equals x dy dx plus y. And then I can subtract y, 1 over cosine xy minus y. And we're going to have to divide that all by x anyway. So over x equals dy dx. And that is clearly not one of the answer choices, but we can get a common denominator here. And then that makes this 1 minus y cosine xy over x cosine xy, which appears to be choice D. Good or no? Any questions there on 16? All right. Y'all are still there, right? I haven't like lost my Zoom, whatever.
Yes, we're here.
Okay. Sometimes
I'm here. I cannot. But
at least two people are here. You responded and somebody else responded in the chat. All right, good news. All right, next one. In fact, this is the last one anybody's actually asked for at the moment. Is number 31. The first derivative of f is x on x cubed minus x. When is f increasing? So all you have to do to figure out when f is increasing is take a look at when is f prime positive. And so I still don't have a functioning graphing calculator here on my computer again, so we'll just graph it on Desmos and take a look, which is kind of like cheating because it makes it so easy. But that's fine. And let's see, let's do this. We'll just restrict our domain so we're not even looking at a bunch of extra values. And we wanted to know when is it positive or when is it negative? Is it increasing or decreasing? Positive. Okay, so we're looking for when is it increasing, so when is it positive? Well, it looks like it's positive from 1 to 1.691. Which is not, oh yeah, it is. There is the answer choice. I knew it was on there somewhere. 1 to 1.691. And you'll note that they said closed intervals, they didn't put brackets, they did less than or equal to because they're talking about when is a function increasing or decreasing, and you should always indicate that it's brackets or closed intervals. Everybody good there with 31?
yes.
Wonderful. Anybody else have any other questions? Those are all the ones that people put in the chat, I think, unless I missed some. Nobody's got any questions from the 2012? Oh, 45. Okay, all right, here we go. Exciting. We got another problem to do. It's good. I was getting bored not having any problems to do. It'd be really cool if my laptop would work properly. Oh yeah. I did this one. I think I did this one last period. The problem with the river and the city, etc. All right, so here we go. Number 45. We've got a city that is located beside a river. It's got a rectangular boundary. We know that the population density of the city at any point along a strip that is X miles from the river's edge. So this is our X direction here. The density of a strip of land, so this like really narrow, thin strip of land here, this has a density of f of x. Okay. So the density is related to how far away we are from the river's edge. We don't actually know what f of x is, so we don't know if it's getting more or less dense as you move away from the river, but we know that that x value, when you plug it into that function, gives you the density. We want an expression for the population of the city. Well, we should probably figure out the population in a strip of land here. The population in the strip of land ought to be the density times the area of that cross section. And we want to integrate that from 0 to 4 miles from the city's edge to add up each of these little tiny, very thin strips. And so, as we said a minute ago, our density is just f of x. Our area is the length of the strip, which is 7, times the width of the strip. Well, what's the width of each of these little tiny strips of land? They're very small, very, very, very thin pieces in the x direction. So it should look something like that. And it looks like they pulled a constant of 7 out to the front of the integral. But other than that, that's what we should get. Good or no? Questions on that one? All right, next one somebody just asked about again here is 22. 22, we did 22 already today. Didn't we do 22 already today? Yeah, we did 22.
Yes, we did.
Yeah, with a rumor spreading, right? So we well, just quickly go back through it again. We the no, you meant the no calculator section. 22 is from the next section. You talking about the 2012 number 22? Oh, you did want 45 from 2008 though, yeah? Not 45 from, okay, all right, so I've done one problem that you wanted me to do. Okay, so we want number 22 from the next test. Okay, exciting times. People are leaving. Oh, goodbye. Sorry that my class has bored you. All right, 22. Let's see here. Oh, cool. My Wi-Fi is really working really great right now. Gotta wait for this to load so I can see what the problem is. There we go. I got it now. Oh yeah, it's gonna be, the Wi-Fi is gonna just be spectacular when all the kids are back on. Well, not all of the kids, but many of you, some portion of you are back on campus. They got me set up for 15 kids. Oh, did you guys see that I think they said that they're gonna do 4 days a week though for people that are coming back instead of 2. Did you guys see a thing about that?
I didn't, but I wouldn't be surprised. Yeah.
Yeah, exciting. How many of you are coming back to not my class? You would go back if it wasn't just Zoom in person, yeah. Yeah, I get that. I don't know. I mean, I'm sending my kids back because go back to school, kids. I need you back in school. I mean, otherwise they'll just be sitting at home alone, and that's not good for an 8 and a 12-year-old that don't like each other. All right, number 22 from 2012. we got f of x equals ln x over x. What's the absolute maximum of f? So what we do is we take our derivative, f prime of x, and this is the quotient rule. It's a function divided by another function. So we should get x for the denominator times the derivative of natural log of x, which is 1 over x, and then minus ln x times the derivative of x, all over x squared. And so we end up with 1 minus ln x over x squared. And we end up with two potential critical values. We look at the numerator equaling 0 and the denominator equaling 0. Well, one gives us 0. 0 is not defined on our original function, both because you can't take the natural log of 0, also because you can't divide by 0. So this is not a critical value. But 1 minus ln x equals 0 tells us that ln x equals 1 and x equals e. And so then what we need to do, there's two things we need to do here. First thing we need to do is we need to check and see if this actually gives us a max rather than a min. So if we plug in something less than e, like let's say 1, we end up with 1 minus 0, which is positive, over a positive, so we get positive. So we're increasing, and something greater than e, like 10 million, gives us a negative in the numerator and a positive in the denominator. So we clearly have a max at e. But then you look at the answer choices and you go, oh my gosh, there's no value of e. And that's what a lot of people do here because they don't carefully read. What is the absolute maximum value of f? Not where does it occur? The max occurs at e. But the actual max is f of e, like iron. Is that the right chemical element? It's been so long since chemistry. You get 1 over e. Choice B. Does that make sense to everybody?
So here we don't have to check the actual value against others because there's only one critical value that works, right? But if there were more, we'd have to compare them with each other.
That is correct. Or if there were endpoints to this, but this does not have any closed endpoints either. And I mean,
So if
you wouldn't have to worry about endpoints anyway, because you know it's less to the left of E and more, right? And also less to the right of E. But
so when they ask for absolute max, should we also check limits if it's on both sides?
no.
Like to infinity.
I mean, okay, so if you check towards infinity, it's not going to be an absolute max. Like if something's always increasing, right? It's never going to, you know, like if it's always increasing as x goes towards infinity, there's not going to be a max over there then. You just need to check to make sure that it's not increasing. Like you could have a function, I'll sketch it on the next page. Like a lot of times, especially with functions that have e or u to the x or something like that in them, or natural logs in them, you might end up with something that does like this. And so like this would indicate, so let's say this is, I don't know why I'm acting weird here. This has no absolute min because this is going down forever, clearly not approaching a horizontal asymptote. But it does have an absolute max because this value up here is clearly higher than any other value if this is approaching an asymptote out here, let's say. So you might, your end behavior might show that, okay, we have a local max, we have a local min, and then we're increasing, right? Your sign chart might look something like this. Might look like positive, so increasing, negative, so decreasing, positive, so increasing. But that doesn't tell the whole story because we have an asymptote here that's cutting this off. So this would have an absolute max, even though it might look like it doesn't, because your sign chart says it's increasing forever. You have to note that it's increasing to a horizontal asymptote. So it's slowly, slowly, slowly increasing, but never actually getting past this value of 0 or whatever it may be. Does that help? Does that make sense?
Yeah.
Cool. Other questions? 2C from the 2008 free response. Okay. Let's see here. Put a clipping of this in here. All right, 2C. So we got a concert, we're given a chart. The function L of t is the number of people, not a rate, but a number of people waiting in the line. And we're looking at 2C. So for 0 to 9, it says, what is the fewest number of times at which L prime must equal 0? Well, L prime would equal 0 if L goes from increasing to decreasing or from decreasing to increasing. So, and we know that this is a differentiable function. So every time that it goes from increasing to decreasing or decreasing to increasing, L prime had to be 0. So here we're increasing from 120 to 156. 156 to 176, we're still increasing. But somewhere in here, we started decreasing again, right? So there's at least one place where L went from increasing to decreasing. So at least one place where the derivative equals 0. Then here, to go down to 126, but back up to 150 is the second place. And then for going up to 150 and down to 80 is a third place. And then it continues down. So there are at least 3 times. And we would say L of t changes from increasing to decreasing, or vice versa, 3 different times. So we know that it happens once between 0 and 4. Really, we could say between 1 and 4. Once it happens between 3 and 7. And another time it happens between, what is it, 4 and 8. So at least 3 times, once on each of those intervals. Does that make sense?
Yes.
Wonderful. Other questions?